25 x square minus 1. No, if we assume ये book क्यों नहीं हो रहा है? You know, if we assume u is equal to 25 x square minus 1. Okay, so you know du becomes 50x dx. Okay, you know derivative of x square is 2x, so therefore du over dx actually becomes 50x. Therefore du actually becomes 50x dx. So you know so this equation actually implies x dx is equal to du over 50. So you know we replace 25 x square minus 1 by u, and x dx is replaced by du over 50. Okay, so you see we bring this 50 outside from the integral. Now the integral actually becomes very simple. It is 1 over 50 integral 1 over 50 integral square root u du. So you know it is u to the power half. So we apply the formula of integration. So it becomes u to the power 3 by 2 divided by 3 by 2. So you know now we replace this u by 25 x square minus 1. So you know by making the substitution, what we have seen, if we replace u by 25 x square minus 1, can easily be integrated. Important thing is, you know, square root 25 x square minus 1 is there. If we assume this 25 x square minus 1 by u, whose derivative is, you know, 50x x dx, which is there. So therefore, it can easily be integrated. Example, in case of example number 3, we have integral x over square root 25 x square minus 1 dx. Again, you know, in this case, this square root contains 25 x square minus 1, whose derivative is here x dx. So therefore, we use the same substitution, u is equal to 25 x square minus 1. So when we replace this 25 x square minus 1, so du actually becomes 50 x dx, or you know we can say x dx actually becomes du over 50. So you see this function actually reduces to 1 over square root u du over 50. So you know again the integral of 1 over square root u, you know, it can easily be determined. It will be equal to square root u divided by half. So you know by making this substitution, we have find the integral. Okay, although you know these integrals involve it is the product of two functions, you know, in example number 1, although it is a product of two functions, we did not apply integration by parts formula. Substitution actually simplifies the integral. So therefore we have used the substitution. Now this is example number 3. You know, here although we have again square root 25 x square minus 4, but you know if we suppose u is equal to 25 x square minus 4, since its derivative x dx is not here, so therefore this substitution will not work. Here we will use the trigonometric functions. This is the first rule for the trigonometric function. When we have square root b square x square minus a square, so you know for this type of integrand, for this type of function, we suppose x is equal to a over b sec theta. The reason is, you know, when we substitute x when we substitute x is equal to a over b sec theta in this square root, so you know it becomes a square x square minus a square. We bring a square outside from the integral, it becomes sec square minus 1, and we know the sec square theta minus 1 is
please.
Sec square theta minus 1 is basically, you know, tangent square theta. So when we put tangent square theta here, the square root is eliminated. So therefore, for this type of integrand, when we have a square root b square x square minus 1 minus a square, we make the substitution x is equal to a over b sec theta. When x is equal to a over b sec theta, we know the derivative of sec theta is sec theta tangent theta. Therefore, dx actually becomes a over b. So you know in our example, b is b squared is 25. It means b is 5, and a squared is 4. So therefore, uh, you know, a is 2. So therefore, we make the substitution. X is equal to 2 over 5 sec theta. So so therefore dx actually becomes 2 over 5 sec theta tangent theta d theta. So in this integral we will replace x by 2 over 5 sec theta and dx by 2 over 5 sec theta tangent theta in this integral. So you see when we are replacing this substitution. So square root x square actually becomes, from here x square actually becomes 25. This 25 is there. 4 over 25 sec square theta minus 4, and we replace x by 2 over 5 sec theta. This is the value of, dx. So you see here, this 2 over 5 sec theta is cancelled with this, and this 25 is cancelled with this 25. So in the square root we have 4 sec square theta minus 4. So we take 4 common from the square root, so it becomes 2. So when we take 4 common, so it becomes sec square theta minus 1. 2 sec square theta minus 1. So let's see the result. So we left with this 2 square root sec square theta minus 1. We know 1 plus tan square theta is sec square theta. Therefore, sec square theta minus 1 actually becomes tangent square theta. When we put here tangent square theta, this square root actually becomes tangent theta. Okay. तो ये क्या हो जाएगा, इस इंटीग्रल 2 tangent theta into tangent theta. So this becomes square root tangent square theta. So therefore now the integral actually simplifies. It becomes I is equal to 2 integral tangent square theta tangent theta. We don't have any formula for the integral tangent square theta. You must remember, the derivative formula. We know derivative of sine theta is cos theta. Therefore, we say the integral of cos theta is sine theta. Derivative of cosine theta is minus sine theta. Therefore, integral of sine theta is minus cos theta. We know the derivative of sec theta is sec theta tangent theta. So therefore, integral of sec theta tangent theta is sec theta. However, the the derivative of sec, the derivative of derivative of tangent theta is sec square theta. Therefore, we say the integral of sec square theta. So we will change this tangent square theta into sec square theta. By making the substitution, tangent square theta is sec square theta minus 1. Since we know the integral of sec square theta is tangent theta. Since the derivative of tangent theta is sec square theta, therefore integral of sec square theta is tangent theta. So this integral sec square theta becomes tangent theta, and the integral of 1 is theta. So next we apply this reverse substitution. We replace this tangent theta by basically yes, this is tangent square theta. Actually, we will replace this tangent square theta is sec square theta minus 1. So this tangent theta actually becomes square root sec square theta minus 1. There is a typing error here. This is tangent square theta. Okay, tangent square theta is equal to sec square theta. So we replace this tangent theta by square root sec square theta minus 1. As we have earlier, we assume x is equal to 2 over 5 sec theta. So therefore sec theta becomes 5 over 2x. So we will replace here this sec theta by 5 over 2x. And from here the theta is equal to sec inverse, and this theta will be replaced by sec theta inverse 5 over 2x, or we can replace this theta by theta is equal to cos inverse 5 over 2x. So finally we replace sec theta by 5 over 2x and theta by this I. So finally we obtain the integral. Okay, this is the final answer. So what we have seen, by making the trigonometric substitution, we can find the integral of this type of function, where we have we have the integrand of this form, b square root b square x square minus a. So whenever we see the integral involves square root b square x square minus a square, we make the substitution x is equal to a over b sec theta tangent theta. Okay, let's see the another type of substitution. uh, let's see another example, number 4. you know in this case, the integrand involves uh, square root 9 minus x square. So this is the another type of substitution. This is not b square x square minus a square. This is 9a. This is now the general form is this. We have, whenever we have the integrand of this form, square root a square minus b square x square, we make the substitution x is equal to a over b sine theta. When we replace this x is equal to a over b sine square theta, this term b square x square actually becomes a square sine square theta. And we take a common a square, so we left with square root 1 minus sine square theta. We know this 1 minus sine square theta is cos square theta. In this way, we eliminate square root. So, whenever we have this type of integrand, the integral which involves this type of functions, square root a square minus b square x square, we make the substitution x is equal to a over b sine theta. So, therefore, dx actually becomes a over b cos theta d theta. In this, in our example, a square is 9. So, therefore, a is equal to 3, and b square is 1. So, b is 1. So, therefore, we make the substitution x is equal to 3 over 1 sine theta, or it is simply x is equal to 3 sine theta. Therefore, dx actually becomes 3 cos theta d theta. So, we will substitute x by 3 sine theta and dx by 3 cos theta d theta. So, we make the substitution. So, then the original integral actually becomes, instead of here we have the x to the power 4, so it becomes 3 sine theta to the power 4 square root 9 minus 3. So here we replace x by 3 sine theta. This 3 cos theta, this is cos theta, sorry, cos theta d theta. So now we will simplify. This square root actually become 9 minus 9 sine square theta. We will take common 9 from the square root. So it becomes, let's see, this is 9. This is, again, this is cos theta. This is cos theta. So we will take this 9 common outside from the integral. When we take the this 9 common from this square root, so it becomes 1 minus sine square theta, which is equal to cos square theta. Therefore, this square root actually becomes 3 cos theta. Okay, so it becomes 3 cos theta. This 3 cos theta is cancelled with this 3 cos theta. So now the integral actually becomes the integral 1 over 81 sine to the power 4 theta. So 1 over sine to the power 4 theta can be written as cosec to the power 4 theta. Again, we express this cosec to the power 4 theta as cosec square into cosec square 4 theta. We will convert this cosec square theta into 1 plus cot square theta. This cosec square theta, okay. You see, when we substitute u is equal to cot theta, derivative of cot theta is minus cosec square theta. So that's why I have changed this cos square theta by 1 plus cot square theta. So we will make substitution u is equal to cot theta. So du actually become minus cosec square theta. So it becomes, this integral becomes 1 over 81. This becomes 1 plus u square and minus du. This cosec square theta d theta actually becomes minus du. So minus minus du. This is this is the typing error. This is not theta. This is minus du. Okay. This is minus du. Okay, let's me write down here. This is actually, this is typing error. This is du. Okay, this is du. Okay, so so now this actually, this is a algebraic function. We know how to determine the integral of 1 plus u square. The integral of 1 is, du. Integral of, uh, u square is u cube over 3. Really careful. So, so therefore, here I have written the integral of 1 plus u square. It becomes u plus u cube over 3. Now we will apply the backward substitution. We will replace, u is equal to cot theta, and then uh, we have started from this substitution. X is equal to 3 sine theta. So therefore, sine theta is x over 3. Now we want to express this cot theta in terms of x. So therefore, we from this identity, cos theta is square root 1 minus sine square theta. Put the value of sine square theta is, x over 3. So, by putting the value sine square theta x by 3, so we get cos theta. Finally, we obtain the value of cot theta, which is, cos theta over sine theta. So, which is equal to, so, cot theta is square root 9 minus x square divided by x. So, in this equation, we replace cot theta by square root 9 minus x square divided by x. So finally, we obtain this integral. This is the final answer of the problem. So you have seen whenever we have an integrand of the type, square root a square minus b square x square, we make the substitutions. X is equal to a over b sine theta. So we have discussed two types of trigonometric substitution. First type was square root b square minus a square x. I mean x b square x square minus a square. So in earlier case we have assumed x is equal to a over sec theta. In this case we assume a over b sine theta. Okay. Let's see the another type of trigonometric substitutions. In this problem, this is the integral we want to know. Here we have this integral of the type square root 1 plus 36 x square. This is the another type. This is the square root a square plus b square x square. So in this case, a square is 1, therefore a is 1, and b is 6. So whenever we have the integrand of this type, square root a square plus b square x square, x square. So we assume x is equal to a over b tangent theta. Here we will assume tangent theta, since we know 1 plus tangent square theta is sec square theta. In this way, this square root will be eliminated. So that's why we make the substitution. I mean, x is equal to a over b tangent theta. So therefore, the derivative of tangent theta is sec square theta. So dx actually becomes a over b sec square theta d theta. So in our problem, a is 1 and b is 6. So therefore, x is equal to a over 6 tangent theta. So dx actually becomes a over 6 sec square theta d theta. So we will replace x by 1 over 6 tangent theta and dx by 1 over 6 sec square theta d theta in the original integral, in this integral. Okay, replace x by 1 over 6 tangent theta and dx by 1 over 6 sec square theta. So finally when we make the substitution, our integrand actually becomes, this is x to the power 5 actually becomes 1 over 6 tangent theta, and here we have 1 plus tangent square theta. Okay, and you see we simplify here. We know 1 plus tangent square theta is sec square theta. So this it becomes you know sec sec to the power cube. Okay, so this is 1 plus tan square theta to the power 3 by 2. When we replace 1 plus tangent square theta by sec square theta, so this function actually becomes sec cube theta. And sec cube theta is simplified with this sec square theta. It will be cancelled out. So we left with this integral. I integral actually becomes, this is sec cube theta. We will cancel out this sec square theta by from the sec cube theta. So we left with this. Okay, now we will change this tangent theta and sec theta in terms of sine and cosine functions. Tangent 5 theta, it will be equal to sine to the power 5 theta divided by cos to the power 5 theta, and this sec theta is 1 over cos theta. We will, when we substitute this functions, we replace these functions, so we get this integral sine to the power 5 theta and cos to the power 4 theta. In previous lecture, we have seen when there is a product of sine and cosine functions, so one power is here, or we will break this sine 5 theta, sine to the power 5 theta, we will express as sine to the power 4 theta multiplied by sine theta. This is the sine, this sine to the power 4 theta, it can be expressed the sine square whole square. Okay, and we know the sine square theta is 1 minus cos square theta. This is the value of sine square theta. So sine, this I'm converting this sine to the power 4 theta in term of cosine theta. So it becomes 1 minus cos square theta whole square. So in this way, actually, I have converted sine to the power 4 theta in cosine functions. By keeping this sine theta, the reason is I will make u, when I replace u is equal to cos theta, its derivative is here sine theta and d theta. So in the next step, I will make the substitution. U is equal to cos theta, therefore du is equal to minus sine theta d theta. So we replace cos theta by u, and sine theta d theta by minus du. So we come with this result. Okay, by making this substitution, now 1 minus u square, it will be equal to u to the power 4 minus 2u square, plus 1. Okay, so then it will be divided by u to the power 4, so we will be left with polynomial. It becomes u to the power 4 minus 2u to the power minus 2 plus 1. Now this is algebraic function. We know how to determine the integral u to the power, integral of u to the power minus 5 minus 4 actually becomes u to the power minus 3 divided by minus 3. So we left these are the integral of these polynomial functions. Finally we will replace u is equal to cos theta. So now in this case u is replaced. I'm applying the backward substitution. Replace u by cos theta. Then initially we have started with x variables. We had assumed x is equal to 1 over 6 tangent theta. Now we want to replace this cos theta in term of x. Since x is equal to 1 over 6 tangent theta, so tangent theta, it will be equal to 6x. And we know 1 plus tangent square theta is sec square theta. Therefore, 1 plus sec square theta will be 1 plus 36x square. So it implies cos square theta is 1 over 36 x square. So in our solution, cos theta is apparent, so therefore we will replace cos theta by 1 over square root 1 1 over square root 1 plus 36 x square. Finally we obtain this result. So we have learned trigonometric substitution. We use 3 types of substitutions for different integrands. So let us summarize the result. What we have seen, when the integral involves the function of this type is square root b square x square minus a square. We make the substitution x is equal to a over b sec theta. And when we have a second type of integral, that is, square root a square minus b square x square. So we make the substitution x is equal to a over b sine theta. When we have square root a square plus b square x square, we make the substitution x is equal to a over b tangent theta. So for the three different types of functions, we use three different trigonometric substitution. For the first case, we assume this x is equal to a over b sec theta. For the second case, we use x is equal to a over b sine theta. For this third type of function, we use x over b tangent theta. So this is the summary of the trigonometric functions. Let's see another example. Although, in this problem, example number 6, it is not the perfect square. So, this 2x square minus 4x, it can be it can be converted into perfect square. Let's see how we will convert. We are considering this 2x square minus 4x minus 7. So, you take 2 common from here. So, when you take 2 common, it becomes 2 bracket x square minus 2x minus 7 over 2. So, in order to make this x square minus 2x perfect square, we will add a plus 1. So, plus 1 minus 1. So, therefore, x square minus 2x plus 1 actually becomes x minus 1 whole square. And this minus 1 minus 7 by 2 actually becomes minus 9 by 2. So, now this actually can be written as 2x minus 1 whole square minus 1. So, in this way, we are converting this integral. This integral actually now it becomes square root x square. I mean, x minus 1 whole square root 2x minus 1 whole square 2. So, this is the type of, this in, it becomes, this is the type, our integral. So basically, in this case, we have the first type of transformation, x square minus, so, therefore we will assume, I mean, x minus 1 as, in this case, b square is 2. So therefore b is square root 2, a is 3. So we make the substitution x minus 1 is equal to 3 by square root 2 sec theta. So this is the first type of transformation. We replace x by sec theta. So we therefore, here we assume x minus 1 is equal to 3 over square root 2 sec theta. Therefore, x is equal to 1 plus 3 over square root 2 sec theta. Dx actually becomes, derivative of sec theta is sec theta tangent theta. So, therefore the, for this integral, this original function actually is reduces in term. So they basically, this become 9 sec square theta. So, this become 3. We take this 9 common outside from the square root. So this is, square root 10 square theta, which becomes tangent theta. So, we substitute all this transformation. So as we have seen, the value of x is 1 plus 3 over square root sec theta. And this value of this square root is 3 tan theta, and dx is, so, next we simplify on the right hand side of this equation. This tan theta is cancelled with this tan theta. And, this sec theta is multiplied with this 1 plus 3 square root 3. So, finally we get this integral. Again, we know the integral of sec theta is ln sec theta plus tangent theta, and the integral of sec square theta is tangent theta. We know the derivative of tangent theta is sec square theta. Therefore, integral of sec square theta is tangent theta. So, it simplified. Finally, we will replace. So we have started from this. Okay, I mean, x is equal to, we make the substitution, x minus 1 is equal to this thing. Now we will apply the backward substitution. We will replace the tangent sec theta in term of x by making the substitution. I mean, sec theta is equal to square root 2x minus 1 over 3, and tangent theta is this value. So finally we get, answer. Let's see the example number 7. You can see here, although there is no algebraic functions, Here we have the exponential function, but the square root is appearing here. You see, when we assume x is equal to, so basically this is x is equal to e to the power x. So basically it becomes 1. When we assume u is equal to e to the power x, it becomes 1 plus u square, and this becomes u square. So therefore, we make the substitution. I mean, we assume we want to convert this exponential function into the algebraic function so that we can use, I mean, the trigonometric substitutions. Okay, so therefore we assume u is equal to e to the power x, so du actually becomes e to the power x. The original integral actually becomes, this okay, let's see. So we decompose e to the power 4x as e to the power 3x, e to the power x. So therefore, now it is e to the power x whole cube, and this is, 1 plus ex whole square, and e dx we have rearranged. So this is, u first term, first factor of the right hand side, it becomes u cube. And this is square root 1 plus u square, and this is, du. So, in this way, we have changed the exponential function into the algebraic function. Now, our integrand involves square root 1 plus u square. Here we will use the substitution u is equal to tangent theta. So, by the third type of trigonometric substitution, we assume u is equal to tan theta. So therefore, du is equal to sec square theta. So therefore, square root 1 plus u square becomes 1 plus tan square theta. So therefore, it becomes sec theta. So, we substitute all these substitutions in this integral u cube. Instead of u cube, we write down integral tangent cube theta, and it becomes sec theta, and this du actually becomes sec square theta. We simplify, it becomes sec cube theta. Now we will change this tangent theta and sec theta in sine cosine functions. Let's see. Oh, let's see. Let's see. So basically, okay, let's, what I'm doing here. We have started, e to the power, just a minute. So here we will making the substitution ex tangent theta, and e to the power x dx, it will be equal to, okay, so so again square root 1 plus x square actually become 1 plus x square, it is sec theta. Let's see that. Finally, we will change again in the exponential functions. I don't know, there is no need of this exponential function. You directly decompose the original function. Let's see, the original integrand is, integral tan cube theta sec cube theta. So, we will decompose sec cube theta in this way, and we will by making, we know, I mean, sec square theta can be written, tangent square theta is, sec square theta minus 1. We replace, and we combine sec theta tangent theta. So in this way, we are converting this entire function in the sec square theta. So finally, by making u is equal to v is equal to sec theta, this simplify the integral. And finally, we obtain the solution. Then we will make backward substitution. We will convert this theta into x function. You see here. So this, in this way we have seen how to evaluate the integral which involve, I mean, the square root a square minus x square, or a square square root a square plus b square x square, or a square x square minus b square. So we make trigonometric substitution. Is it okay?